Hello, welcome to week 4 of the Compete with Code.uk C# challenges. Remember, the whole point of these activities is to boost your confidence in problem solving with C# code. And you can only get confidence if you have experience, and you can only get experience if you regularly practice. So these activities give you an opportunity to have a bit of support as you regularly practice. Last week, we went through the ASCII times challenge. So this week we'll go through last week's next letter challenge. We'll start with that. There's 2 new challenges this week. I'll go through prime in this video, and I'll leave you to work out word count. Remember, the sooner you do the activities, the more points you get. So let's start off with next letter. You get given a function template. The function has to accept one parameter called letter. If it contains one character in that string, you should return the next character in the alphabet. And if it's a Z, then it should wrap back round again to an A, and it's case sensitive, so a lowercase z expects a lowercase a. If you get a string that doesn't contain one character, or that contains something that's not a letter of the alphabet, then it should just return a space instead. So let's load some code that works and have a look and see how I've attempted it. There's all sorts of different ways of approaching this. First of all, I've got some logic on here to check and see if we get a capital Z, it wraps it round. Remember, return breaks out of the function, as in as soon as you return, it doesn't run the rest of the code inside that function body. So we check and see if we've got a capital Z or a lowercase z. Then we do some validation and we say so this is a length check here. If there's only one character in our string, so this is the parameter here, then we can try and find the next character. Otherwise, it will return a space because it's invalid. It's failed the length check. So how does it get the next character in the alphabet? Well, first of all, we get the first letter in that string. So a character is an individual letter, but a string can have multiple characters. So first of all, we need to just get one of them. So each character has a number. We usually use ASCII, or perhaps we could use Unicode or UTF-8 or something like that. It's basically a number for each letter. So then we can compare. We can say if the character that we're interested in, the first letter of this string, the only letter of this string, because we're making sure it only has a length of 1, if that number is greater than the number for a capital A, so notice as a string we're using double quotation marks. An individual character in C# we use single quotation marks. So if the letter we're interested in is somewhere between capital A and capital Z, so this is a logical AND. If it's between A and Z, logical OR, it's between A and Z lowercase, then we can just increase the numerical value of that character, convert it to a string, and return it. So if we run it, hopefully, every letter should just be moved on in the alphabet, and it works. The new challenge for today is a prime number test. So this is done a lot in computing. The algorithm I'll give you is particularly inefficient. I'll leave you to try and work out how to do this in a more efficient way. I don't give you the function body for this, so it has to be static because you can call it without needing an instance of the class. It should return a Boolean value. The function needs to be called isPrime, and it accepts one argument. We'll have one parameter, and I'm just going to call it n. The function body must return a value that is either true or false. So it shouldn't have any syntax errors, but it will fail all of the tests, or at least some of the tests. Let's have a look and see. Oh, this has failed. Identifier expected, static bool isPrime. Oh, I didn't say what data type the parameter was, so that needs to be an integer. Let's try this. Shouldn't be a compilation error anymore, but it has failed the test. Here we go. So a 1 should be not prime, but my algorithm says that it is prime, and that's wrong. It's failed the test. Okay, so first of all, let's work out what we mean by a prime number. A prime number has to be bigger than 1. And it also has to be only having a factor of itself and 1. If it has any other factors, it's not prime. So let's see. If n is less than 2, then it's definitely not a prime number. We'll return false. But if it has any factors, then we can return false, because it shouldn't have any factors between 2 and a certain amount. But if we don't find any factors, then it is going to be prime. So let's see. If. So how do we check for factors? Well, first we need to loop around to check for all of the possible values. We'll use a for loop for that. So int I equals, now we don't want to start at 0 or 1, because everything is a factor of 1. Let's start at 2. And I'm going to make my algorithm fairly inefficient. You can work out how to make it more efficient by changing this value. So I'll go up to n, not including it. And then for each value of I, we'll check and see if I is a factor of n. Remember, n is the parameter that we've passed in. In this example, n is going to be 100. So if n divided by I, keeping the remainder rather than the result of the division, so using the mod operator, if the remainder is 0, so we've got nothing left over after we've divided, that means it's a perfect factor. It divides in perfectly. Then we can return false, because it shouldn't have any factors if it's prime. So let's have a look and see if it works. Probably not. Yeah, awesome. So I have updated the algorithm this week. If you get an error message, it should actually point to the line of code in here. Before, it pointed to perhaps the wrong line number, which made it rather difficult to debug. Next week, I will go through the solutions for word count, but you have a go at that one. You have to accept a string and work out how many words there are. But it should be intelligent enough to not just count spaces, as in if there's a tab or multiple spaces in there, it should still only count the words. I'd recommend using regular expressions for this. If you can work out how to do that, I'll go through next week, but there are all sorts of different solutions for you to work through. All the very best, and look forward to seeing your scores coming through this week. Bye-bye.